In this part of 3.3, we're going to talk about rate of change, which is really nothing more than slope. It's just a specific type of slope. We still have that change in y over the change in x, but our change in y is going to be a little bit different because we're going to look at how something changes over time. That might be, now we'll look at a couple examples here. It might be speed, it might be money. It could be a lot of different things that would be like your change in y. Now the change in time, that's basically just your change in your x values. So the examples that I came up with here would be maybe speed. We can look at miles per hour. So your miles is like how much it changes, that's your y, and then your hours, how much your time changes. Feet per second would be another example of speed. I came up with a rent one also as an example, $100 per month. Another one that might be common to you is how much you get paid. Most of you are probably paid on an hourly wage, so your dollars per hour would be another rate of change. Here I have an example of a problem dealing with some rate of change. We have, for one manufacturer of camping equipment, between 1990 and 2000, annual sales increased by $7.4 million per year. Now, I'm just going to stop right there because I notice we have $7.4 million per year. Right there, there's an example of a rate of change because we have something in the dollars changing per time being the year. All right, now I'm going to move on. Now in 2000, the total sales were at $85.9 million. And it says if sales increased at the same rate that we had up there before, what will be the total sales in 2010? Now, one way to do this is we can look at this $7.4 million as a slope per 1 year. Now we need to figure out how many years we're going to increase at that $7.4 million. Well, it tells us a beginning time and a beginning dollar amount, and then it tells us an ending time, 2010. So what we can do is we can take that 2010, we can get rid of or subtract out the 2000, and I know that's some pretty easy math. You can probably just do it in your head. But then we're left with 10 years. So we need to figure out how much more we're going to make after a 10-year span of time. Now we start at $85.9 million. So at $85.9 million, and we start there. And now we have to do this for 10 years. So we're going to have to add on some dollar amount. And I'm going to add on then how much we're going to gain over those 10 years. Well, here's where the rate of change comes in. We have this $7.4 million. Should probably put the million on here so we don't forget that. There's a slight difference between $7.4 and $7.4 million. And then this is over 1 year. But then if we multiply this by those 10 years that we are going to increase our sales, let me just circle what I'm going to do. This part right here is going to give us that change in 10 years. Well, when I multiply that, I'm going to end up with $74 million, because notice our years will divide out, and the only label left is $74 million. Then I still have my, and again I forgot my million on this, but $85.9 million here. I'll stick it in up there. And now when you look at this, I have millions of dollars for both of them. I need to add them together. So when I do my math and I add all this together, I end up with a grand total of $159.9 million as my answer. Now, what's that the answer to? Well, I go back to my question. It says, what will be the total sales in 2010? So I'm going to have total sales of $159.9 million in 2010. And there's one little example on rate of change.